In this video, I'll be building some simple LED circuits in preparation for future projects. As I've said in other videos dealing with electronics, I am a total noob in this area, so I am sharing with you how I understand these things to work at the time. If you spot an error, please leave a comment letting me know. Okay, let's get started. First off, here's what I will be working with today. I have both 9V and AA batteries, a 9V battery clip and AA battery holders, LEDs, resistors, a toggle switch, and wires with alligator clips. Light-emitting diodes. The pieces: anode, the longer wire connected to the positive side of the battery; cathode, the shorter wire connected to the negative side of the battery. The current flows from the battery to the anode, across to the cathode, emitting light, and then back to the battery. Apply too little current and the LED won't light up. Apply too much and it can burn out. Let's start off as simply as we can. The white LED that I have takes 3 volts to light up, and each AA battery puts out 1.5 volts. So 2 of them together should power the LED. We just connect everything together and the LED lights up. Now let's try adding more LEDs. This time let's use 3 red LEDs. Each red LED requires 2 volts, so 3 of them together need 6 volts. If we use 4 AA batteries, we will have the 6 volts that we need. Next, if we wanted to use 3 white LEDs, we would need 9 volts. So let's wire that up using the 9V battery. But now what happens when the LEDs require a voltage that we can't exactly provide? So far this has been easy. The voltage the LEDs require has exactly matched the power supply we've used. If the voltage we provide is too high, it could damage the LEDs. There's a solution: use a resistor. Resistors are what are used to resist or limit the amount of current flowing through a circuit. So we have a 9V power supply and we want to use 2 red LEDs and a single white LED. The red LED requires a range from 2 to 2.2 volts, and the white LED requires a range from 3 to 3.2 volts. Doing the math, that means we need a voltage range of 7 to 7.6. What are volts anyway? The common analogy is to think of volts like water pressure in a pipe. Our LED can only handle so much pressure, so we have to lower the pressure in the entire system in order to not damage the LED. That's where the resistor comes into play. It can handle some of the pressure burden so that our LED doesn't get damaged. But resistors come in an incredibly wide range of sizes, so how do we know which one to use? Well, we could use some math and formulas, or we can use this web-based LED resistor calculator and just let it tell us the required resistance we need. If we provide the calculator with 3 of the 5 values, it can calculate the others for us. Our voltage source is the 9V battery, so we enter 9 here. The voltage from the LEDs we added up earlier, and that was 7.6. The current through the LED was written on the package, and it's 20 milliamps for both LED types. Now we can click the calculate button to see the results, and it says we need a resistance of 70 ohms. Now my collection of resistors doesn't have a 70 ohm resistor, so we will round up to the closest value that I have, and that would be 100 ohms. Let's insert the resistor between the battery and the first LED and connect the battery. There we go, 2 red LEDs and 1 white LED shining brightly. So far we've been wiring the LEDs in series, meaning each LED is connected to the next, splitting the voltage out amongst all of them. This is perfectly fine when you have a small power source and only a handful of LEDs, but what if you need more? Say like 4 3V LEDs, but you only have a 6V battery. In those situations you can wire the LEDs in parallel instead. Since we're getting a little more complicated in what we are wiring, let's use a breadboard for building the circuits. I gave a breadboard introduction in my Raspberry Pi controlling RGB LED strip lights video. So instead of rehashing the content, here's that segment. Next up is the breadboard. A breadboard is a device used for prototyping circuits. It's solderless, so we can just push components into it instead of soldering them together. But how does it work? Along the edges are 2 bus strips for power. One the supply voltage, often shown in red with a plus sign. The other the ground, shown in blue or black with a negative sign. Each bus is a row of contact points running from right to left. In the middle of the board is a gap. The gap isolates the 2 sides of the breadboard. Between the outer buses and the gap are the terminal strips. These strips are isolated in columns from front to back, separated and isolated by the gap. Let's start by building a circuit with 2 white LEDs and a 6V power supply so that you can see what something familiar looks like on the breadboard. You see we have the positive and negative wires connected to the breadboard's corresponding positive and negative buses. Next we connect the LEDs in series with some jumper wires, then we connect the positive and negative wires. Flip the switch and the LEDs light up. Next we'll add a second set of LEDs in series and wire those up the same way as the first. Now when we flip the switch, all 4 LEDs light up. The voltage across each set of LEDs is still just 6 volts. but the current draw from the battery has doubled from 20 milliamps to 40 milliamps. This does mean that the battery will drain faster. Let's take the circuit we just built and increase the power supply from 6 volts to 9 in order to show you how to incorporate resistors into the circuit. Now back in the web-based LED resistor calculator, enter 9 for our source, 6.4 for the voltage drop, and 40 milliamps for the current, which remember is double what it was for powering a single series of 2 white LEDs. Now we get a resistance value of 65 ohms, but again I will need to round up to the next resistor size I actually have, which is 100 ohms. Instead of connecting the jumper wires from the first LED to the power bus, we will connect 2 100 ohm resistors to it instead, and then 1 resistor to the first LED in each series. Now flip the switch and all 4 LEDs once again light up. We've really just scratched the surface of LEDs here, and if you're interested in learning more about them, I'd recommend Adafruit's All About LEDs guide for starters, Make Electronics from Make Magazine, or if you really want to dive deep, Practical Electronics for Inventors. I have included links to all of these in the description below. Well, that's it for this video. If you enjoyed it, please give it a thumbs up and share it with others. If you've not already, go ahead and subscribe to the channel and click the notification bell to be alerted when new videos drop. See you next time.